Hey guys, welcome back. This is your first pre-calc video of 2021, and it's going to be a quick one. We're just going to review what we covered before break because I know it's been a while. For me, it feels like it's been forever, so you're probably in the same boat, right? So recall before break we were studying rational functions, and these were functions that are built like fractions. So I have a polynomial on top, polynomial on the bottom, a fraction bar in between them, right? And one of the properties that these things have is that their graphs are not continuous, right? So in other words, I cannot draw this graph. This, by the way, is the graph of f from Desmos, f of x. I cannot draw this graph in one try without picking up my pencil, right? There's a gap in there, okay? And the work we were doing was finding where these gaps are, right? So this one, it's pretty clear to me where that gap is. We have a vertical line at x equals 0, right? Remember, that's called a vertical asymptote. So that line that the graph approaches but never touches is called an asymptote. So we want to be able to find that from the function analytically by doing some algebra. Okay. So the move here is to factor both the top and bottom, right? So I can factor and rewrite f. So f of x would be on top, well, x plus 4 times x plus 1. And remember, all I did there was one of these guys, right? I used your x method that you guys like, and I got 1 and 4. And then on the bottom, well, notice there's a common factor here. 3 is in both of my terms, and also there's an x in both my terms. So I'm going to pull out a 3x, backwards distribute, right? And what is left over is just 1x here for my first term, and then what times 3x gives me 3x? Well, 1, right? Okay, so remember the domain of our function is going to be affected by what's on the bottom here. And specifically, we know we cannot divide by 0. Dividing by 0 is undefined. Okay. So we need to think about what numbers, what values of x are going to make the denominator equal to 0. Right? So right away we say, well, that's where 3x equals 0 and where x plus 1 equals 0, right? So that's x equals 0 and x equals negative 1. Okay. So x equals 0, so right away we can say that that's our vertical asymptote, right? And that's what we were expecting based on the graph. And then what about x minus 1 here, right? So x minus 1 also makes our denominator as written equal to 0, and you could even plug it into our original f to check, right? But that point x minus 1 is filled in on my graph. Well, this is where Desmos lies to you, right? So if Desmos graphed this accurately, it would draw a little hole at x equals negative 1 right there. Okay. So if we're ever face to face again, I'll ask you to sketch these graphs on paper, and you would draw a little hole there, and you would do a better job of graphing it than the computer would. So this x is a hole. This x is a vertical asymptote. And let's remind ourselves why. So as I look at f of x, notice x plus 1 appears in the top and bottom. Well, x plus 1 over x plus 1 is just a fancy form of 1, right? So those terms actually cancel out. So that's the difference, right? The whole canceled out of my function, right? Made the denominator equal to 0, but then canceled out. Whereas my vertical asymptote did not cancel. kind of an unfortunate color combination I picked here. Okay, so the last thing we need to know how to do is notice my vertical asymptote, it's for any y, right? It takes up the whole y-axis. But holes have a y to go with their x. So we know that this hole occurs, we have a hole at -1, comma, something, some y, right? And I would guess based on my graph, it's at -1. But let's make sure we know to be sure. Okay. So to check that, what I can do is I can bring down my function f, but just what's left over after I've canceled out those terms. So x plus 4 over 3x, because my x plus 1's canceled out, right? And then I'm going to plug in -1. I get -1 plus 4 over 3 times negative, and let's get my face out of the way here. That gives me 3 on top and -3 on the bottom, which is -1. Okay. So I plugged in my x, got a y, right? And that confirms what I'd see on the graph. Okay. So that last piece, checking where the hole is the piece we were kind of stuck on, I think, a little bit before break. So hopefully that is helpful to you. I do want to show you what this looks like on your graphing calculator. So if you have access to your TI-84, I've graphed it in here as well. So the way I typed it in is just a little fraction bar in parentheses, right? And I just typed it in as it appears. And notice when I graph it, I get that same shape, and that hole doesn't really show up either, right? So again, you're going to have to be a little bit smarter than the graphing calculator. But what is helpful is if I go to the table, so second and then graph to get the table, notice it gives me error at x equals 0 and at x equals -1. Okay, so that you're still going to have to do a little bit of work to figure out what is what, but that is a good helpful hint to look at the table for these guys to kind of confirm your work here. Okay. If you're feeling stuck, the week 14 video also goes over similar problems, goes over a couple more. I also upgraded our Delta Math account, so you can also watch the Delta Math videos on these as well. So that should be, you'll see a link to it as you're working through the problems. As always, if you're still stuck, reach out if you have any questions.